Assalamu alaikum, dear students. Let's move to the next part of redox reaction chapter. Here we will continue the calculation of oxidation number by taking some special examples. Let's see. H2O2, hydrogen peroxide. Now here you are going to calculate what is the oxidation number of oxygen. As we know that in the rules, oxygen is always, its oxidation number is taken as -2, right? But there are some conditions. If it is in its peroxide form, we take it as -1, and if it is in superoxide form, it will be taken as -1/2, right? And when it is combined with fluorine, that time it shows positive oxidation number. So here let's see what oxidation number you will get over in this compound. Okay, then you can tell whether it is a oxide or peroxide or superoxide. Okay, तो अब ऑक्सीजन का चार्ज मालूम करना है तो हाइड्रोजन का हमको पता है, हाइड्रोजन का चार्ज कभी भी आपको क्या लेना है, 1, राइट? सो हाउ मेनी हाइड्रोजन ओवर हियर, 2. सो यू विल राइट 2 into 1 plus how many oxygen atoms, 2. You will take it as 2x equal to 0, right? So 2 into 1, 2 plus 2x equal to 0. 2x is equal to -2, or you will get x is equal to -2 divided by 2, that is equal to -1. So you are getting oxidation number of oxygen as -1, means this compound is a peroxide compound, right? So we call this actually compound is hydrogen peroxide. So in peroxides, oxygen charge will be -1, right? Same way, if I take KO2, KO2. So in KO2, if you find out what is the oxidation number of oxygen, let's see. Potassium alkali metal, so its charge will be taken as 1 plus oxygen. Oxidation number has to be calculated. How many oxygen here? 2. So you will write 2x neutral molecule. So we equate it equal to 0. So 2x is equal to 1 will come on this side. It will become -1, and x will be equal to -1/2, right? So -1/2, you are getting the oxidation number for this oxygen, means it is a superoxide ion. Next example, CrO5. You are asked to calculate what is the oxidation number of chromium in this compound, right? So as usual, chromium will be taken as x plus how many oxygen? 5. Oxygen charge, we take it as -2. You will equate it to 0, right? So x -10 equal to 0, x will be equal to 10, right? So you are getting x equal to 10, means oxidation number of chromium is 10. But here one important point you need to check is, when you talk about oxidation state, it will be dependent on its valency or the valence electrons. Say for example, when you have chromium electronic configuration, you write its atomic number is 24. It is written as Ar 4s1 3d5, right? Means chromium can involve maximum 6 electrons in bonding. Chromium can involve maximum 6 electrons in bonding, right? Because these 6 electrons are treated as valence electrons for chromium. Means when you talk about oxidation number, it is nothing but you can also compare it with, to some extent, with valency, where valence is nothing but number of electrons involved in bonding. So here if you are getting 10, it is wrong actually. Okay, means either your calculation will be wrong, or some of the oxygen present in this compound may be in peroxide form, because you should not get the oxidation number of chromium more than 6. It can be less than 6, but it cannot be more than 6, right? So once you get oxidation number more for a particular element from its expected values, so it nothing but it means that either the calculation may be wrong, or some of the oxygen atoms may be in peroxide form, right? So that time what you have to do, the better way to understand the correct oxidation numbers is you can go with the bonding and the structure of that molecule, right? If you check out the structure and bonding of that particular molecule, then you will come to know what is the exact oxidation number of particular element in that compound, right? So if you go with this CrO5, its structure is like this. Chromium will be written at the center, one oxygen here, another oxygen here, third, and this is fourth, and this is fifth, right? So this CrO5 is having a butterfly shape structure. What type of structure? Butterfly shape of structure. Okay. So here, this is the structure. Now from this structure, we can easily find out what is the oxidation number of this particular chromium in this compound, right? Let's see. Chromium and oxygen. More electronegative element is oxygen compared to chromium. So this electron pairs which are shared between these two atoms are more shifted towards oxygen. So 1 and 1, 2 electrons will be shifted. So here we assign charge as -2. ओके, जब भी दो अलग अलग एटम के बीच में बॉन्डिंग होता है तो इलेक्ट्रॉन पेयर ज्यादा किसके तरफ शिफ्ट होते हैं? मोर इलेक्ट्रोनेगेटिव एटम की तरफ। तो मोर इलेक्ट्रोनेगेटिव एटम की तरफ जितने भी इलेक्ट्रॉन शिफ्ट होंगे उतना चार्ज आप असाइन करेंगे। तो दो इलेक्ट्रॉन यहाँ पे शिफ्ट होने वाले हैं, तो यहाँ पे आएगा चार्ज -2 और इस क्रोमियम को मिलेगा चार्ज +2, राइट? Same way, we'll check here. Chromium and oxygen, single bond is there, means single electron pair is shifted towards oxygen. So here it will get -1 charge. Why -1 now? Here it was -2 because two bonds were formed. Here one bond is formed, so one electron pair is shifted towards oxygen. So it will get one extra minus charge. That electron from chromium is also shifting towards oxygen, right? So once it is getting -1, chromium will be getting +1. Same thing happens here also. This oxygen will get -1. This chromium will be getting +1. Here also oxygen -1, chromium +1. And the same thing here also, -1 and here +1. So we can see how much is the total charge now for chromium. 2 +1 3 +1 4 +1 5 +1 6. So you got the charge, the oxidation number of chromium as +6, right? And here we can check what are the charges obtained by the oxygen atoms. Out of 5 oxygen atoms, one oxygen atom is getting -2 charge. The other 4 are having -1 charge. Now to finalize, here also one more bond is there, here also one more bond is there. Here what happens, both the atoms are oxygen atoms, electrons will be equally shared. So that time electron will neither shift on this side or this side, they are equally shared. So if I write also, I have to write 0 charge, 0 charge. 0 here also, 0 here also, because electrons are equally shared between the same atoms. Okay, so net charge on each of these 4 oxygen atoms is -1, and this oxygen atom is carrying -2 charge, right? If you take these values and calculate, see what answer you will get. I'll take chromium as X plus how many oxygen? 5 out of 5. One oxygen atom is having -2 charge plus 4 oxygen atoms are having -1 charge equal to 0, right? So X -2 -4 equal to 0. x will be equal to plus 6, right? So if you go with the structure, if you check the bonding, you will clearly get the idea that what is the oxidation number of particular element in a compound. So in CrO5, oxidation number of chromium is plus 6, right? If you do it the calculation and show the answer as plus 10, it will be wrong. So it should be plus 6, right? S2O3 2 minus thiosulfate ion, right? It is called as thiosulfate ion. When it is combining and forming some salts, it will be called as thiosulfate salt, right? So let's see what is oxidation number of sulfur you will get over here. So oxidation state of sulfur has to be calculated. So we'll take sulfur as 2x, as there are 2 sulfur atoms, plus 3 oxygen, 3 into minus 2 equal to minus 2, right? Charge on the ion will be equated with the charge on the ion. So here 2x minus 6 equal to minus 2. 2x is equal to minus 2. Minus 6 on this side you will take, it will become plus 6. So 2x is equal to 4, and x you will get 4 divided by 2, that is equal to 2. You are getting oxidation number of sulfur as 2, right? Now for sulfur also, when you talk about its electronic configuration, atomic number is 16. So you will be writing neon 1s2, 2s2, 2p6 over 3s2, 3p4. This sulfur can become stable by gain of 2 electrons, right? So its lowest charge can be minus 2, or it can become stable by the loss of these 6 electrons. Means it can show maximum charge as plus 6. Means totally it can involve 6 electrons in bonding, right? It can involve 6 electrons in bonding. So its oxidation number will range from minus 2 to plus 6. इससे ज़्यादा नहीं आएगा और इससे कम नहीं आएगा, राइट? इसका ये रेंज है. तो हर एक एलिमेंट का ऐसा रेंज हो जाता है, मिनिमम एंड मैक्सिमम. उससे ज़्यादा नहीं हो सकता और उससे कम नहीं हो सकता, क्योंकि उससे ज़्यादा होने के लिए नोबल गैस कॉन्फ़िगरेशन से इलेक्ट्रॉन निकालना पड़ेगा. उससे कम होने के लिए नोबल गैस कॉन्फ़िगरेशन से ज़्यादा इलेक्ट्रॉन्स आपको ऐड करना पड़ेगा, राइट? So this will be the range where these sulfur can show its oxidation number from minus to minimum, maximum it can show plus 6. Now here you are getting plus 2. You can have oxidation number of sulfur as plus 2 also, but this is a special case. When you check its bonding, sulfur less number of atoms are written at the center, oxygens will be shown at the end. If it is having hydrogen, it is shown completely at the end of the structure. So 3 oxygen atoms, I'll write one here, and one here. For becoming stable, sulfur totally it is having how many electrons? 6 electrons, right? So 1 electron it will share with this oxygen atom, 1 electron it will share with this oxygen atom. Still it is having 4 electrons. Out of 6, it has shared 1 electron with this oxygen and shared 1 electron with this oxygen. Oxygen requires 1 more electron to become stable. So to make it stable, we'll write minus charge here. Same thing here also, minus charge, right? So this oxygen will become stable by sharing the 2 electrons from sulfur. Okay, we can show it by coordinate bond. These 2 electrons will be shared by this oxygen. In the same manner, these 2 electrons will be shared by this sulfur atom. Okay. Now this is the structure what we can write, or we can also draw like this. instead of showing coordinate bond, we can show double bond also, because electrons involved, electrons shared between the two atoms are 2, right? Now here, sulfur is less electronegative than oxygen, so this oxygen will be getting -1 charge, sulfur will be getting +1 charge. Here also the same thing will happen. Oxygen will be getting -1, sulfur will be getting +1. And here also oxygen gets -2, sulfur will be getting +2 charge. Okay. Now when you compare these two, right? Even though these two are sulfur atoms, electrons should be equally shared, but this complete electron pair is shared by this sulfur atom. So this sulfur will be getting -2 charge because those electrons are shifted towards this sulfur as it is forming a coordinate bond. So it will be getting 2 electrons extra from this sulfur, it will get -2 charge, and this sulfur will be getting +2 charge. So total charge on this sulfur atom will be +6, whereas this sulfur gets -2 as its oxidation number, right? So here -1 for this oxygen, -1 for this oxygen. So total charge on this oxygen you got -2. Total charge on this oxygen you got -2. Here again 2 electrons are shifted towards this oxygen, -2. Sulfur will be getting +2. From here it will be +1. From here also it will be +1. And here, even though the atoms are same, these electrons are shared by this sulfur, so it is given charge as -2, and because of which this sulfur will be getting +2 charge. So out of 2 sulfur atoms, you are getting 2 as value because you are getting the average value. You are getting what? Average value. When you check the individual oxidation numbers of both the sulfur atoms, one sulfur is having oxidation number as +6. The other sulfur is having oxidation number as -2, right? So this can be understood only when you draw the structure. Okay, because calculated value will be always an average value. It may be sometimes correct, but it may be sometimes wrong or different. Okay, one more example we'll see. S4O6 2 minus, tetrathionate ion. It is nothing but tetrathionate ion. Let's calculate the oxidation number of sulfur here also. So to calculate, you will take it as X. How many sulfur atoms? 4. So 4X plus 6 into -2 oxygen charge equal to, charge on the ion is -2, we'll write -2 here, right? So 4X 6 into -2 is -12 equal to -2. Okay, 4X is equal to -2, -12 on the other side, it will become +12. So 4X is equal to +10. 4X is equal to +10. X will be equal to 10 divided by 4. So here you will be getting a fractional value. Okay, fractional value you are getting. Why? Because you are getting an average of totally 4 atoms oxidation number. Totally you are getting the average value, because average why you are getting is 10 divided by 4, means each oxygen atom is getting 2.5 charge. Fractional why we are getting is because it is an average value, but when you check individually it will be different. When you check individually it will be different, because individual when you check out it will be a whole number, it will not be a fraction, instead it will be a whole number. Fractional value किसके लिए आता है? ये सुपर ऑक्साइड में, right? That is okay, but for other species when you are getting fractional value, it indicates what? It is nothing but it will be an average value of the total number of atoms. So for that sake, again when you check the structure, then you will come to know which atom is having what oxidation number. Let's see. Four sulfur atoms, I'll write like this. How many oxygen? 6. 1, 2, 3, 4, 5, 6. Right? So sulfur is having 6 valence electrons. So it will form 2 covalent bonds, and here the electrons will be shared by forming coordinate bond. ओके ये 2 इलेक्ट्रॉन शेयर करके कोवालेंट बॉन्ड फॉर्म करता है, बाकी के अपने जो इलेक्ट्रॉन्स है वो क्या करता है, दूसरे एटम्स के साथ इन शेयर करके कोऑर्डिनेट बॉन्ड फॉर्म करता है, राइट. सो हियर it will share one electron with this sulfur will share one electron with this sulfur, again this sulfur will share one electron with this sulfur, it continues. अब यहाँ पे क्या होगा, एज यूजुअल यहाँ के जैसा ही यहाँ पे सिंगल बॉन्ड लिखा हूं, यहाँ पे और एक इलेक्ट्रॉन बच गया, राइट. तो यहाँ पे एक बॉन्ड ड्रॉ करता हूं, यहाँ पे डबल बॉन्ड, यहाँ पे भी डबल बॉन्ड. अब यहाँ पे सिंगल बॉन्ड बताया हूं तो एक नेगेटिव चार्ज लिखेंगे, यहाँ पे भी एक सिंगल बॉन्ड, यहाँ पे नेगेटिव चार्ज. तो ये स्ट्रक्चर हो जाता है S4O6 2- टेट्राथायोनेट आयन का, राइट. सी हियर अगेन 6 electrons will be there for sulfur, 1 2 3 4 5 6, right. So what I can do is I will call this as covalent, this as covalent, and these two are coordinate. इन दोनों को हम coordinate treat कर लेंगे, right. अब यहाँ पे सल्फर के पास अभी ये लोन पेयर के जैसा बचे हैं, they have not taken part in bonding because they are involving only 2 electrons in bonding. This sulfur is involving all the 6 electrons in bonding. This sulfur is also involving 6 electrons in bonding, right. तो ये स्ट्रक्चर हो गया. अब स्ट्रक्चर के बेसिस पे आप इसको ऑक्सीडेशन नंबर्स चेक करो. sulfur oxygen electrons are shared. How many electrons are shared? One pair is shared. So electronegative atom is oxygen, it will get -1 charge. What about sulfur? +1. Okay, this oxygen is more electronegative than sulfur, it will get -2, because of which sulfur will be getting +2. यहाँ पे भी वही होगा, सल्फर को मिलेगा +2 और ऑक्सीजन को मिलेगा -2, राइट. तो ये पार्ट लेफ्ट हैंड साइड का हो गया. सेम राइट हैंड साइड पे भी वैसे ही है, राइट. तो यहाँ पे इसको मिलेगा कितना, -1, इसको मिलेगा -2, this oxygen will get again -2. Sulfur, when you talk about, from this oxygen +1, from this oxygen +2, and from this oxygen +2, right. Add up करो, देखो कितना होता है ऑक्सीडेशन नंबर, +1 +2 +2 means how much, +5. Here also +5. ओके. अब ये जो इलेक्ट्रॉन शेयर होगा, ये सल्फर और ये सल्फर के बीच में जो इलेक्ट्रॉन शेयर हो रहा है, okay, whatever electron pair is shared between these two sulfur atoms, it will be equally shared because both the atoms are same, right. Both the combining atoms are same. In previous example, complete electron pair was shifted towards the sulfur atom, but here this sulfur is also forming bonds, this sulfur is also forming the bond. So when both the atoms are same, electrons are equally shared, so both will get zero charge. इसको भी zero मिलेगा, इसको भी zero मिलेगा, राइट. तो ओवरऑल चार्ज इसका हो गया 5, यहाँ पे भी वैसे ही 0 मिलेगा और इसको मिलेगा 0 चार्ज. अब ये दोनों भी सेम एटम्स है, इलेक्ट्रॉन्स इन दोनों के बीच में जो फॉर्म हो रहा है बॉन्ड, ये भी इक्वली शेयर होगा, सो ईच ऑफ देम विल बी गेटिंग 0 चार्ज. सो ओवरऑल व्हाट यू हैव गॉट इज, out of 4 sulfur atoms, 2 sulfur atoms have +5 charge and 2 sulfur atoms are having 0 charge, right. Average what you are getting, 2.5. How? 5 plus 0 plus 0 plus 5, that is equal to 10, divided by 4 you will get 2.5. But actually sulfur 1, first sulfur is having +5, second sulfur 0, third sulfur 0, again fourth sulfur is +5, right. So bonding and structure will tell you the clear idea about the oxidation number of that particular element. Okay. We have some more examples of this type. Br3O8. Br3O8. And we have C3O2. When you find out oxidation number of bromine and carbon, you will get fractional values, but when you check their structure, it will be different. So if you calculate, see what you will get. So you will be taking 3x plus 8 into minus 2 equal to 0, 3x minus 16 equal to 0, 3x will be equal to 16, x will be equal to 16 by 3. Here also 3x plus 2 into minus 2 equal to 0, 3x minus 4 equal to 0, 3x is equal to 4, x is equal to 4 by 3. You are getting fractional oxidation number. Why? Because this again you are getting the average of the 3, right? So if you check the structure, individually you will come to know what is oxidation number of the single atoms, right? So when you draw the structure for this compound, it is written like this: 3 bromine atoms and totally 8 oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So totally 7 valence electrons will be there for bromine. Halogens का oxidation number maximum plus 7 तक आएगा because they have 7 valence electrons in their electronic configuration. Minimum will be -1, maximum will be +7, right? So they have the ability of involving all the 7 electrons in bonding, right? So this bromine will share its 7 electrons in this manner, right? Here 2 bonds, here 2 bonds, here again same as the first. Okay, you can check it now. Bromine is less electronegative than oxygen, or oxygen is more electronegative than bromine. So -2 here, -2 here, and -2 here, right? It will become what? -2 -2 -2 means bromine will be getting here +2 +2 +2, right? And these two atoms are same, electrons will be equally shared. So overall charge of this bromine is nothing but +6. Here this bromine, this oxygen is more electronegative, -2 -2, bromine will be getting +2 +2. Again it is sharing electrons with the same atoms, so equally shared. So this bromine will be having +4 as the oxidation number, and here it is the same as the first, +6, right? So 6 plus 4 plus 6, 16 divided by 3. But individually, 2 bromine atoms are having +6 oxidation number. 1 bromine is having +4 as the oxidation number, right? Here also the same thing happens. C3O2, 3 carbon atoms and 2 oxygen atoms. We call it as carbon suboxide. बॉन्डिंग देखो आप इस तरह रहेगी. Carbon oxidation number ranges from -4 to +4 based on its configuration. 2s2 2p2 आता है. You can remove 4 electrons +4, or you can add 4 electrons -4. It will be in this range, right? Let's see here what happens. इस oxygen को मिलेगा -2 because it is more electronegative than carbon. So this carbon will be getting +2 charge. Same thing here, -2, this carbon will be getting +2 charge. Whereas this carbon, electrons are equally shared with this carbon as well as with this carbon, it will be getting zero charge. Okay, so out of the three carbons, two carbon atoms are having +2 charge, one carbon is having zero charge, right? So these are all special examples, right? They will give you the structure and they will ask you what is the oxidation number of particular atoms in that structure. So you have to carefully find out how many electrons are shifted. Always oxygen will be getting the negative charges, whereas the other element, opposite element, will be getting positive charge. Okay. Last one more example we'll take. H2S2O8. Again, you are asked to find out oxidation state of sulfur, right? This is H2S2O8. Peroxo disulfuric acid. We call it as peroxo disulfuric acid. Let's calculate oxidation number here. So hydrogen, two atoms are there. Its charge will be 1. Sulfur, we take it as 2x plus oxygen 8 into -2. That will become equal to 0. So 2 plus 2x, 8 into -2, we write it as -16 equal to 0. 2 minus 16 is -14 equal to 0. 2x you will get equal to 14 and x will be equal to 14 divided by 2. Answer will be +7. As I have told, sulfur cannot have oxidation number more than +6. Here we are getting +7, right? Means either the calculation will be wrong or the oxygen atoms involved here may be in peroxide form. So for that sake, again you can check the structure. Structure is in this manner for this compound. We write hydrogen at the last ends as it forms a single bond. Right? So this is a structure. See now, sulfur sharing 2 electrons with this oxygen. Oxygen gets -2, sulfur will be getting +2. Here also the same thing, -2, +2. With this oxygen it is sharing 1 electron. So this oxygen will be getting -1, sulfur will get +1. Okay. With this oxygen also it is sharing 1 electron, it will get +1 and this oxygen will get -1, right? And here oxygen is sharing 1 electron with hydrogen, hydrogen gets 1, this oxygen will be getting -1. यानी कि यहाँ पे ये ऑक्सीजन के ऊपर ओवरऑल चार्ज कितना हो गया, -2. Complete part is same here, right? So this oxygen -2, this oxygen -2, this oxygen also -2, हाइड्रोजन 1, सल्फर देखो यहाँ पर +2 आ रहा है, यहाँ से भी इसको +2 मिलेगा, इस ऑक्सीजन से +1 और ये ऑक्सीजन से भी +1 और ये ऑक्सीजन का कितना आएगा, -1. अब बचता है ये बॉन्ड इक्वली शेयर होने वाले इलेक्ट्रॉन्स है बिकॉज बोथ द कंबाइनिंग एटम्स आर सेम. So each of them will be getting 0 charge. Means net charge on this oxygen is overall -1 and here also it will be -1. Means we can see out of 8 oxygen atoms, 1, 2, 3, 4, 5, 6 oxygen atoms are getting -2 charge and 2 oxygen atoms are getting -1 charge, right? So when you talk about sulfur, 2 plus 2, 4, plus 1, 5, plus 1, 6. Sulfur is getting +6. This sulfur is also getting +6, right? So bonding has helped us to find out the correct oxidation number of sulfur, because out of 8 oxygen, 2 are in peroxide form. When you go with the charges considering the peroxide form of oxygen, you will get the correct answer. Means 2 into 1, 2 hydrogen atoms getting +1 charge, plus 6 oxygen atom minus 2 charge, plus 2 oxygen atoms are having -1 charge, plus sulfur 2x I'll take equal to 0. So here 2 ones are 2 and this will be -12. This will be what? -2 plus 2x equal to 0. कितना हो जाएगा? 2x is equal to 12. X is equal to 12 divided by 2, nothing but you will get 6. Right? So this is the correct calculation. If you are taking all oxygen as -2, you will get +7. But when you go with the structure, you will find that 2 oxygen atoms are in peroxide form. Right? So 2 oxygen atoms linked with only single bond. Like this, we call it as a peroxide linkage. Okay. So these are all some special examples where calculation gives you some different value, whereas bonding, the structure will give you the correct and exact oxidation number of a given element. Okay.